Hello dear friends, welcome to MACS College. We are learning engineering mathematics and this is common for all the BTECH BE students all over India. In today's session, we discuss about some important questions on special square matrices. So we try to keep the concepts in a minimal but sufficient manner. So here we can expect the following two important questions. First one is defining symmetric, q-symmetric and orthogonal matrices. The second one is defining Hermitians, q-Hermitian and unitary matrices. Of course, we start with some very basic concepts and we try to understand these definitions properly. First of all, what is a matrix? A matrix is a rectangular array of elements. So here elements can be anything, but we are only interested in numbers. Okay, so for us the elements are numbers, and if the numbers are real numbers, then we call this as real matrix. If the numbers are complex numbers, then we call it as complex matrix. So here I just given an example. In this, if you observe, this particular matrix is having 1, 2, 3, 4, 5 rows and 4 columns. So we call it as a 5 by 4 matrix. So this is called order ya to size of the matrix. And this is the general notation for the matrix, where it is having m rows and n columns. And you see this double subscripts we use. So here this Aij represents ith row and jth column element. So this is first row, first column. It is in the first row and second column. It is in the first row and third column, and it is in the first row and nth column. Similarly, second row, first column, second row, second column, second row, third column, and second row, nth column. Now, if you consider this, this is mth row and first column, mth row, second column, mth row, third column, and mth row, nth column. So we can write it in a short notation like this. This matrix can be represented like this: Aij of order m by n. Instead of writing this big matrix, you can just use this short notation for this. And here Aij represents ith row, jth column element. Now, if you observe this element, it is in the first row and third column. So you can call it as A13. What about this? It is in the third row and fourth column. What is this element? It is in the fifth row, second column. Now I can ask you, what is A43? That is in the fourth row, third column, 1, 2, 3. This is the element. So what is A43? 4. So this double subscript notation you should understand. Okay. So this is about matrix. What is a matrix? A matrix is a rectangular array of elements. If the elements are real numbers, we call it as real matrix. If the elements are complex numbers, we call it as complex matrix. Now we try to understand one very important operation of matrices, that is matrix multiplication. See, suppose you are having a m by n matrix and another n by r matrix. For example, you may be having a 2 by 3 matrix and another one is say 3 by 4 matrix. You can multiply these two matrices only when the number of columns of the first matrix is equal to number of rows of the second matrix. Then only we can multiply them. So, if you can multiply them, we say that they are conformable for multiplication. The matrices are conformable for multiplication. And if you multiply these two matrices, you get another matrix. What is the order of this matrix, my dear friends? The order of this matrix is given by 2 by 4. That is number of rows of the first matrix and number of columns of the second matrix. But before that, you have to check whether they are conformable or not. These two must be same. Then you can multiply and the resultant fellow will be having order m by r. So, it may be called as some C. Let me take one simple example. If you know it, it's good. If you forget, let us see how we can multiply two matrices. So, here it is a 3 by 2 matrix and it is a 2 by 2 matrix. Are they conformable for multiplication? Yes, because this is 2 and this is 2, we can multiply them. So, if you multiply, what is the order of the result, sir? The order of the result is 3 by 2. So, this is a 3 by 2 matrix. That is, it will be having 3 rows and 2 columns. Now, let me show you what is the result, how you get this result. So, here what we need to do is the first row to be multiplied with first column, that is 2 3 6 plus 1 0 0. So, you get first row, first column element. Now, multiply first row with second column, 2 2s 4 plus 1 1s 1. You get first row, second column element. Now, take second row, multiply with first column, 3 3s 9 plus 2 0s 0. Second row, multiply with second column, 3 2 6 plus 2 1s 2. Third row, multiply with first column, 4 3s 12 plus 5 0s 0. Third row, multiply with second column to get third row, second column element, that is 4 2s 8 plus 5 1s 5. So, this is how we get the product, my dear friends. So, this is a 3 by 2 matrix. So, what is the result here? 6, 4 plus 1 5, 9, 8, 12 and 8 plus 5 13. So, this is the product of this matrix. Now, there are some very important properties. Sometimes in objective 1 marks questions, they can ask you. It is good to remember and note these properties. See, actually here you can multiply this L with M, but can you do M into L? Here it is 2 by 2 and it is 3 by 2. These two are not same. This is not possible. Okay. So, sometimes it may not be possible at all. And sometimes, suppose here say A is a 3 by 3 matrix and B is a 3 by 3 matrix. Now, B is 3 by 3 and A is 3 by 3. You can multiply AB and BA, but it is not necessary that they are always same. So, please note that AB need not be equal to BA. We generally call it as commutative property. So, matrix multiplication is not commutative, but association is there. That is, when you are having 3 matrices, you can first multiply these two, then the result can be multiplied with C, or first you can multiply B with C, then the result can be multiplied with A. So, there is no problem. Then we have distributive property. See here, you can multiply A with B and you can multiply A with C. So, you can distribute the multiplication over addition. So, these are some properties. Sometimes they can ask you in your examination. Now, let us understand how to do transpose of a matrix. Suppose you are having a M by N matrix. What is the transpose of this matrix? It is N by N. That is, we are converting rows into columns and columns into rows. So, here suppose it is the matrix Aij. then this is the matrix Bij, where the ith row jth column element of the transpose is jth row ith column element of the original matrix. That is, suppose you are having 3, 2, 1, 5, 7, 9, which is a 3 by 2 matrix. What is the transpose? Simply convert rows into columns and columns into rows. So the first row becomes the first column, the second row becomes the second column. So this is called transpose. Okay, these are all important to understand definitions of the symmetric, skew symmetric matrices, my dear friends, and also orthogonal matrix. That's why I am giving you minimal and sufficient information. Actually, when you transpose a matrix, again if you transpose it again, you get the original matrix. And constant times A whole transpose is simply C into A transpose. So that does not matter. C you can take common. A plus B whole transpose is A transpose plus B transpose, and AB whole transpose is B transpose into A transpose. So sometimes it is important to note these properties, my dear friends. Now let us see some very important square matrices. First of all, what do you mean by square matrix, my dear friends? Square matrix means the number of rows is equal to number of columns. So it is like n by n. So rows equal to columns. So there are some very important square matrices which we need to consider. The first one is diagonal matrix. What is a diagonal matrix, my dear friends? It's a square matrix where we have only main diagonal elements which can be non-zero, but all the off diagonal elements are 0. So in a general notation we can simply call it as it is a square matrix. It is a square matrix. What is important here is these fellows are 0. Main diagonal, if they are 0 or not does not matter, but all the off diagonal elements, we call them as off diagonals. Okay, all the off diagonals are 0. That is Aij is equal to 0 for all I not equal to 0. We call it as off diagonal elements are 0. Off diagonal elements are 0. I will just show you this. If you write a general matrix like A11, A12, A13, A21, A22, A23, A31, A32, A33, here if you observe this diagonal elements, okay, it is like AII form, whereas all these fellows, if you consider, this I and J are different. That is, when I is different from J, then it should be equal to 0. That is the simple meaning. All the off diagonal elements are 0. So that is the idea, my dear friends. Okay. So this is a diagonal matrix. What is important for diagonal matrix? All the off diagonal elements are 0. Main diagonals can be non-zero values. Suppose if off diagonals are 0 and main diagonals, if you restrict to 1, then it becomes a identity matrix. So what is identity matrix, sir? It is a diagonal matrix, but what is specialty here? The main diagonals are all equal to 1. If it is 3 by 3, you see main diagonals are 1, remaining all are 0. Here 2 by 2 you take, main diagonals are 1, remaining all 0. 1 by 1 matrix, only one element, that is 1. You can take order 4th, 4 by 4 matrix also. So only main diagonal fellows are non-zero, 1, and remaining all are 0. Remaining all are 0. So this is your identity matrix. What is the importance of identity matrix, sir? If you multiply a matrix with identity matrix, then the result is same matrix. So that is the beauty of identity matrix. Am I clear? So if you want definition wise, it is like this. It is a square matrix with two conditions. What are the two conditions? Main diagonal fellows are all equal to 1. That is AII is equal to 1 for all I. That is main diagonals are 1. Main diagonals are 1s. And second thing, off diagonals are 0. What is it? Off diagonals are 0. That is it. Then we have upper triangular matrix. So you can see this upper triangular means only this upper triangular elements are non-zero. The lower triangular elements are all zeros. So actually if you observe, it is second row first column, third row first column, third row second column. That is when I is greater than j, then it is 0. So you can write the definition also very easily, sir. What is an upper triangular matrix? You can see this is called upper triangular. Only upper triangular elements are available. All the below main diagonal elements are all 0. If all these fellows are 0, then we call it as upper triangular matrix. So definition wise, if you want to write, all the elements below main diagonal are 0. What is the definition? All the elements below main diagonal are zeros. That is the definition. So if you want mathematically also, you can write Aij of order n by n, and Aij is equal to 0 when I is greater than j. Simply like this you can write, or you can define like this. This is the upper triangular set. Now you can talk about lower triangular. Very simple. Lower triangular means what? All the elements above main diagonal are 0. All the elements above main diagonal are zeros. Okay, see, above the main diagonal all these fellows are zeros. So that is the definition of lower triangular matrix. If you want, you can mathematically also simply say it is Aij, where Aij is equal to 0 when, see here it is like 2 1, sorry 1 2, and it is 1 3, and it is 3 3. Okay, so sorry, it is 3 2. I am very sorry, I will repeat it. So this is first row second column, first row third column, third row second column. That is when I is less than j, then Aij is 0. That is about lower triangular matrix. Now there is one very important method called determinant. I will be giving this determinant method separately also. We will discuss this. Okay. But at least 2 by 2 determinant, if you know, you can understand the definitions of symmetric, skew symmetric and other thing. Mainly for orthogonal matrix we require this, because there we need to find inverse. See, determinant for 1 by 1 matrix is simply that element. If it is 1 by 1 matrix, the element itself is determinant. When it is 2 by 2 matrix, the determinant we denote it like this. Please don't think it as absolute value, sir. It is not absolute value, it is determinant. We read it as det A, and determinant is given by A into D minus B into C, AD minus BC. For example, if you are having a matrix say 4 3 6 2, what is determinant, sir? 4 into 2 minus 6 into 3, 4 2 is 8 minus 6 3 is 18, it is minus 10. Some people have doubt whether determinant can be negative. Yes, it can be negative, no problem. Now finding inverse of a 2 by 2 matrix. Suppose if you are having a 2 by 2 matrix ABCD, what is its inverse? See, actually A inverse definition is adjoint A by det A. I will try to give it separately, this method, later on, but for understanding purpose, if you know direct shortcut also, it is sufficient. Okay, this is actual method, but for 2 by 2 matrix we have a shortcut. You can directly write it as 1 by AD minus BC. So what we need to do is you swap the main diagonal elements and change the sign of off diagonal elements. swap main diagonal elements and change the sign of off diagonal elements. For example, if you are having say 1 3 2 5, then what is A inverse, sir? 1 by 5 minus 6. So main diagonals you swap and change the sign of off diagonal elements. So that is 1 by minus 1. So minus 1 into 5 minus 3 minus 2 1. When you multiply with minus 1, it is minus 5 plus 3 2 minus 1. Okay. See, what is the advantage of this, sir? A inverse. If you multiply A with A inverse, we should get identity matrix. You want, you can verify that, sir. If you multiply A with A inverse, what is A inverse, sir? If you multiply with A, you should get identity matrix. That is what you call it as inverse, my dear friends. Okay, it is called multiplicative inverse actually. Now let us take one more example. What is inverse of this matrix? This, let us call it as A. Then what is A inverse, sir? 1 by 1 into minus 5, that is minus 5, minus 1 into minus 4, that is minus 4. Main diagonal you swap and off diagonal sign is changed. So it is minus 5 plus 4, it is minus 1, minus 5, 4, minus 1 and 1. So when you multiply, you get 5 minus 4 plus 1 minus 1. So this is how we find inverse of a square matrix. Now let us start with the important questions. What are the two important questions which I given? First important question is define symmetric, skew symmetric and orthogonal matrix. So the definition for symmetric matrix is a square matrix is symmetric if A transpose is A. That is, if you transpose the matrix, you should get back the same matrix. If the transpose of the matrix is same, then we call it as a symmetric matrix. Now look at this. Look at this matrix. Now let us transpose this. Transposing means what? Rows are converted to columns. So first row becomes first column, first column becomes first row, second column becomes second row. You see, you got A transpose is A. Okay. So this idea is actually ith row jth column elements are equal to jth row ith column elements. That is, if you consider this main diagonal as the mirror, these fellows are exactly mirror images. You can try this even for 3 by 3 matrix, my dear friend. Suppose if you are having a 3 by 3 matrix, main diagonals can be anything, sir, no problem. But here suppose if you are having 6, because this is the mirror, so here we will have the mirror image. This number will be 6. Suppose it is say minus 3, the mirror image is minus 3. Suppose it is 7, then this is 7. You can check what is transpose of this matrix. It is exactly same as A. That's it. So in the exam, if they ask definition, you can just write, and if you write one example, it is sufficient. Up to here, if you write, it is sufficient. If you want to give more information, you can give one more example. A square matrix is symmetric if A transpose is A. Okay. So it is symmetric, then find ABC value. Symmetric means what? This must be equal to 4. This must be equal to 2. And this must be equal to 3. Second definition. A square matrix is skew symmetric if A transpose is minus A. A transpose is minus A. So consider the following example, sir. See, in skew symmetric, if you observe, the main diagonal elements are zeros. Main diagonals are zeros, and these two fellows are minus of each other. That is, the mirror images are not equal here, they are minus of each other. So those are the simple properties of a skew symmetric matrix. If you want, you can just take the transpose of it. First column becomes first row, second column becomes second row. And here it is like minus of 0 to minus 2, 0, that is minus A. So A transpose is minus A. Okay. So here main diagonals are zeros, main diagonals are 0, and you know the mirror images are minus of each other. Mirror images are minus of each other. This fellow and this fellow are not equal, they are minus of each other. That is skew symmetric matrix. Now I will just give you one example. Here I given a skew symmetric matrix. You just need to tell me what are the values of A, B, C, D. It is skew symmetric means main diagonals are 0. So A is equal to 0 and E also equal to 0. The mirror images must be minus of each other. So B should be minus 1, C should be minus 2, and D should be minus 3. Extra information I am giving. Now there are two important questions which they ask within the symmetric and skew symmetric. Like, you know, they give you that A is a square matrix, then what can you say about A plus A transpose? If A is square matrix, what can you say about A minus A transpose? Or they can ask you, A is square matrix, then A plus A transpose is symmetric, A minus A transpose is skew symmetric. Okay. So they can ask you, prove that A plus A transpose is symmetric. They can ask you, prove that A minus A transpose is skew symmetric. The idea is simple, sir. Whenever any matrix you need to prove it as symmetric or skew symmetric, first take the matrix and take whole transpose of it. And I given a property A plus B whole transpose is A transpose plus B transpose, that is A transpose whole transpose, and that is nothing but A transpose plus A, which is exactly same as original matrix. Is it not like a transpose of a matrix is same as matrix? Therefore, what can you say? A plus A transpose is symmetric. Now let us see the second one. You need to prove it is skew symmetric. See, whether you need to prove symmetric or skew symmetric, na, take the matrix and take whole transpose of it. What is it? A transpose minus A transpose whole transpose, and this is A transpose. A transpose whole transpose is A, and this can be written as minus of A minus A transpose. That is, the matrix transpose is minus of the matrix. Therefore, this matrix is skew symmetric. This matrix is skew symmetric. You can try this two problems also. Prove that this matrix is what? Prove that this matrix is what? So story is same, sir. Whatever he gives, take the matrix, take whole transpose. You know AB whole transpose is what, sir? B transpose into A transpose. So this is second matrix whole transpose into first matrix transpose. A transpose whole transpose is A, so it is A into A transpose. That is, transpose of the matrix is same matrix, therefore it is symmetric. Therefore it is symmetric. You can try this problem also, sir. What can you say about this? B transpose AB. Any matrix if we give, just to take transpose of it. Just to take transpose of it. So what is it, sir? Reverse order you write. First last matrix transpose, next matrix transpose, first matrix transpose. This is B transpose into A transpose into B. But here you can't say anything. It depends on whether A is symmetric or skew symmetric. This depends on whether A is symmetric or skew symmetric. If A is symmetric, this will be A. So it depends on, if prove that if A is symmetric, then this is symmetric. If A is Q symmetric, then this is Q symmetric. So it depends on the value of A. Okay. So if A is symmetric, what happens? This is A transpose is A, so you get B trans AB, therefore it becomes symmetric. Therefore B transpose AB is symmetric. So whatever A is symmetric, then it is symmetric. If A is Q symmetric, it is homework for you. Prove that if A is Q symmetric, B transpose AB is Q symmetric. This is one more important question which they can ask you in examination. Prove that every square matrix can be uniquely expressed as sum of a symmetric and skew symmetric matrix. So what we do here? So here we take the matrix. See, the idea here is, we know that A plus A transpose is symmetric and A minus A transpose is skew symmetric. We use this idea. So we write A is equal to half into A plus A transpose plus half into A minus A transpose. You can write it like this. Yes or no? Yes, because if you write half of this plus half of this, what happens? Half A plus half A will be full A. Half A transpose minus half A transpose cancels. So these two fellows cancels, you are going to get A. Now here this fellow is symmetric and this fellow is skew symmetric. So you can just prove that A plus A transpose is symmetric. First let us prove this. You can always take the same example like A plus A transpose whole transpose is what? A transpose plus A transpose whole transpose, that is A transpose plus A. So A plus A transpose is symmetric because transpose of the matrix is same matrix. Second, let us prove A minus A transpose is skew symmetric. Sorry, A plus A minus A transpose is skew symmetric. How to prove it is skew symmetric, sir? Take the matrix and take transpose of it. So what is it? A transpose minus A transpose whole transpose. So it is A transpose minus A. This is nothing but minus of A minus A transpose. Therefore this fellow is skew symmetric. And now you can write A as a sum of symmetric and skew symmetric matrix. Sum of symmetric and skew symmetric matrix. Therefore A, now A can be written as half of A plus A transpose and half of A minus A transpose, where this is a symmetric matrix and this is a skew symmetric matrix. This is one of the important theorem. If you write this much, it is enough, sir. You will get full marks. For this theorem, this is the proof. Okay. You just need to prove these two parts are, one is symmetric and the other one is skew symmetric. Then A is nothing but sum of symmetric plus skew symmetric. Sometimes this kind of examples also can be given, sir. Express the matrix as sum of symmetric and skew symmetric matrix. So you just take this as A, then you find A transpose. Transpose means first column becomes first row, second column becomes second row, third column becomes third row. So you have to do two things. One is A plus A transpose, the other one is A minus A transpose. So how to do A plus A transpose? Corresponding elements you just add. 2 plus 2 4, 4 plus 6 10, 8 plus 3 11, 6 plus 4 10, minus 4 plus minus 4 minus 8, 6 plus 5 11, 3 plus 8 11, 5 plus 6 11, 7 plus 7 14. Am I clear? Now what about A minus A transpose? Corresponding elements you subtract, that is 2 minus 2 is 0, 4 minus 6 is minus 2, 8 minus 3 is 5, 6 minus 4 is 2, minus 4 minus of minus plus 4, minus 4 plus 4 0, 6 minus 5 is 1, 3 minus 8 is minus 5, 5 minus 6 is minus 1, 7 minus 7 is 0. So now you can write this matrix A as A is equal to half of A plus A transpose, that is this matrix, and half of A minus A transpose, this matrix. So this is A plus A transpose you write here, and here you write A minus A transpose. Okay. Now the third definition. So we completed two definitions. What is symmetric matrix? A transpose is equal to, symmetric means what, sir? A transpose is equal to A. What is Q symmetric matrix? A transpose is minus A. Then what is orthogonal matrix? Orthogonal matrix is one where A transpose is A inverse. That is, transpose is inverse of the matrix. A transpose is A inverse. See, in other words, actually you know A into A inverse is equal to identity you get. A multiplied with A inverse you get identity. But here in orthogonal matrix, because transpose is A inverse, if it is orthogonal matrix, what happens, sir? You can multiply A with A transpose, you get identity. Not for all the matrices, only for orthogonal matrices. Only for orthogonal matrices. So check whether it is orthogonal or not. So what you need to do, you take A into A transpose. That is matrix A, which is cos theta minus sin theta, cos theta. A transpose. What is transpose of this, sir? Cos theta sin theta minus sin theta cos theta. Now you can multiply these two matrices, and for your information, if you do not know, cos square theta plus sin square theta must be 1. Cos theta into cos theta is cos square theta, minus into minus plus sin square theta. So cos square theta plus sin square theta is 1. And here cos theta into sin theta minus sin theta into cos theta. So if you want, you can just write down the details. So here you get cos square theta plus sin square theta. Here you get cos theta sin theta minus sin theta cos theta. And here you get sin theta cos theta minus sin theta cos theta, or cos theta sin theta. Then it is sin square theta plus cos square theta. So when you simplify, you know this is 1, these two get cancelled, you get 0, this is 0 and this is 1. Because A into A transpose is identity, it is orthogonal matrix. Okay, please understand. So for a given orthogonal matrix Q, find the inverse. See, he says it is orthogonal matrix. What do you mean by orthogonal matrix? Don't do like, you know, some people for this matrix, find inverse means what they do? Adjoint Q by determinant Q. Don't do that, because it is orthogonal matrix means what? Orthogonal means Q transpose is Q inverse, or Q inverse is Q transpose. So he is asking what is inverse? Just transpose the matrix. First column becomes first row, second column becomes second row, and third column becomes third. Okay, so these are the three important definitions, my dear friends. Okay, hope you can remember them. So what I do is, I'll just quickly give you the three definitions. Minimum, if you know this much, then your examination is done. Okay, what is symmetric matrix? A transpose is A. Example. So here you can have any numbers, but whatever number is here, same number should be here. What is skew symmetric matrix? See, in the examination, if they ask definition, at least this much if you ask, you will get marks, full marks. A transpose is minus A. So for this, you keep main diagonals 0 and these fellows are minus of each other. If it is 5, then it is minus 5. Orthogonal matrix. What is it? A transpose is A inverse. So you can remember this, 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2 is the example. So if they ask in the examination, this is the answer. Define symmetric, skew symmetric and orthogonal, this is the answer. I also given additional information. If you want, you can write the total information or only this much. Enough. Now before defining Hermitian, skew Hermitian and unitary matrices, we should know what are these complex matrices. See, complex matrix means what, sir? Whose elements are complex numbers. Okay. So if the elements are complex numbers, then you call it as complex matrix. Of course, you can also have real number like this, no problem. Now, what is conjugate transpose? What is conjugate means? For every complex number, you need to write conjugate. Suppose if A plus IB is the complex number, what is the conjugate? Suppose this is the complex number, the conjugate is denoted by Z bar. What is conjugate, sir? A minus IB. So here it is 2 minus I, that is plus is changed to minus. 4 plus 2I, 3 plus 2I and 5 remains S. Now what is conjugate transpose? That is conjugate and transpose. After doing conjugate, you transpose. Transpose means converts columns to rows, rows to columns. That is first column becomes first row and second column becomes second row. That is what you mean by conjugate transpose. Because here we are going to use conjugate transpose, first you should understand. Now let us define Hermitian, skew Hermitian and finally unitary matrices. What is a Hermitian matrix? A complex square matrix A is Hermitian if the conjugate transpose is same as matrix A. Conjugate transpose is same as matrix A, then we call it as a Hermitian matrix. Okay. So here, what is the condition for Hermitian matrix, sir? See, whenever it is Hermitian, the main diagonals will be real numbers. These two fellows are conjugates of each other. Okay. So example you can easily remember. If it is 2 plus 3i, the conjugate you write down 2 minus 3i. Done. That is Hermitian matrix. Main diagonal should be real numbers. That you keep it in mind. So if you want, you can remember, you can verify this, sir. Verification I am doing it. What is conjugate? For real numbers, they are same. These fellows like this becomes 2 minus 3i and this becomes 2 plus 3i. Then what is conjugate transpose, sir? Convert columns to rows and rows to columns. That is 1 plus 1, 2 plus 3i, 2 minus 3i and 2. And you see conjugate transpose is same as matrix A, therefore it is a Hermitian matrix. Now what about skew Hermitian? Conjugate transpose is minus A. Conjugate transpose is minus A. See, here it is complex analog of skew symmetric matrix. Okay. So for this, what happens, sir? For skew Hermitian matrix, what should happen is the main diagonals can be either 0 or purely complex numbers. Okay. So let me keep it like 1, 2i. And what about this fellow? Off diagonal elements, see, they must be like minus conjugates of each other. Suppose if it is 2 plus 3i, the real part sign will be different. Real part sign will be different, imaginary part is same here. So minus conjugates we call them as minus conjugates. So if you just check this, conjugate is what, sir? I becomes minus I, this becomes 2 minus 3i, and this becomes minus 2 minus 3i, and it becomes minus 2i. And if you do transpose of this, minus I, minus 2 minus 3i, 2 minus 3i, minus 2i. So take this minus sign common, so that it becomes I, 2 plus 3i. So if you take I common, it becomes minus 2 plus 3i, and it becomes 2i, which is nothing but minus c. So please note, the main diagonals can be pure imaginary numbers, and these two fellows are minus conjugates. That is, real part sign is different, imaginary part sign is same. That is how we can easily create Hermitian matrices, my dear friends. Please note that point. That is very, very important. Now, before moving to that unitary matrix, we should know how to find inverse of a complex matrix. Story is same, sir, only complex numbers you will be having. You remember this formula? If A is ABCD, then what is A inverse? 1 by AD minus BC multiplied with transpose swap the main diagonal, change the sign of off diagonal elements. So here, if you call it as A, then what is A inverse? One by 3 plus 2i into 3 minus 2i minus into minus plus I square, and here the main diagonals are swapped, off diagonal sign is changed. So if you multiply them, those who do not know, I square is minus 1. Here it is A plus B into A minus B, that is A square minus B square, that is 4I square, which is nothing but 9. I square is minus 1, minus of minus plus. So 9 plus 4, 13, and this is minus 1. So it is like 13 minus 1, and this is like 3 minus 2i minus I 3 plus 2i. So it is 1 by 12, 3 minus 2i minus I 3 plus 2i. Now what about this unitary matrix? So unitary matrix means A conjugate transpose is A inverse. That is, when you multiply A with its conjugate transpose, you should get identity matrix. When you multiply A with its conjugate transpose, you should get identity matrix. Why, sir? Because normally A into A inverse is identity, but here A inverse is what? A inverse is conjugate transpose. So instead of this, I can keep A conjugate transpose, and still I can get identity matrix. So that is the idea. So prove whether it is unitary or not. So how to prove it is unitary? A into A conjugate transpose, if you get 1 0 0 1, then it is unitary. So for this, first of all, find A conjugate. So 1 by root 2, this is minus I by root 2, this is minus I by root 2, and this is 1 by root 2. What is transpose of this? Conjugate transpose. 1 by root 2 minus I by root 2 minus I by root 2 and 1 by root 2. Now let us multiply A with A conjugate transpose. If you get identity, then it is unitary. See, generally in the examination they ask, prove that this is unitary. Prove that this is unitary. Directly you need to ultimately show the answer is 1 0 0 1. Remember that. So you multiply these two fellows. 1 by root 2, I by root 2, I by root 2, 1 by root 2. So this is conjugate transpose is 1 by root 2 minus I by root 2 minus I by root 2, 1 by root 2. So when you multiply them, 1 by root 2 into 1 by root 2, 1 by 2. I square minus 1, there is one more minus sign, so minus of minus plus 1 by 2. 1 by root 2, so it is minus I by root 2 plus I by root 2. Minus I by root 2 plus I by root 2. Here also it is I by root 2 minus I by root 2. And this is I square is minus 1, there is a minus sign, minus of minus plus 1. 1 by 2 and it is 1 by 2. So when you simplify this, you get 1, 0, 0, 1. Because A into A conjugate transpose is identity, therefore it is unitary. Okay. So let me quickly give you the definitions for these three. What do you mean by Hermitian, my dear friends? Hermitian means A conjugate transpose is A. Example for Hermitian is what? Okay. Here we should have some real numbers, and suppose if it is 2 minus 4i, then it is conjugate 2 plus 4i. The skew Hermitian. The skew Hermitian. What is skew Hermitian, sir? A conjugate transpose is minus A. So what should you have? The main diagonals you can have 0 or the pure complex number, and here the real part sign will be different. Suppose if it is 3 plus 2i, then it is minus 3 plus 2i. Imaginary part sign will not be changing, same, but real part sign is different. Then comes unitary matrix. What is unitary matrix? A conjugate transpose is A inverse. And the famous example for this is 1 by root 2, I by root 2, I by root 2, 1 by root 2. Remember that. So A into A conjugate transpose, you get identity. So this is about definition of Hermitian, skew Hermitian and unitary matrices. Thank you.